Okay, so in the last video, we introduced this idea of a mole. Okay, and if you remember, a mole is just a way to count things. So a mole is 6.022 times 10 to the 23rd items. Okay, so you can have a mole of anything as long as you have 6.022 times 10 to the 23rd of that thing. All right. So today what we're going to look at is we're going to look at how to do some conversions with it, okay, or what do you actually do with this. Okay. Remember, our reasoning, why is this important, is because chemistry happens on an atomic level, okay, so it happens on an atom-to-atom basis, and I have to know how many atoms I have in my reaction. So the first conversion we're going to look at converting from moles so moles to particles. And before we do that, let's look at this same concept. You guys are really familiar with it, with like a dozen. So if I say a dozen, 1 dozen is equal to 12 items. Okay, so if I have 2 dozen, I have 2 times 12 to give me what? 24 items. Okay. Or if you say you had 36 items, and I want to know how many dozens that is. Well, you know in every 1 dozen there are 12 items. So the things would cancel out, and you have 36 divided by 12, or you have 3 dozen. So most of the time I notice that students, they can do this 10 times out of 10, all this stuff with dozen. It's the same concept with a mole, because what is a mole again? A mole is just a number of things. Just how many things? It's 6.022 times 10 to the 23rd. Okay, so let's look at some mole conversions. Same concept as dozen here, but it's just with a little bit larger number. So let's do an example. How many atoms are in 2 moles of oxygen? How many atoms are in 2 moles of oxygen? Well, in this case, my items are atoms, okay? But what we're doing here is just like the dimensional analysis that we've been doing all year. So my number that I'm starting with is 2 moles, so I know I have 2 moles, okay? Well, I don't want moles in my final answer. I want atoms in my final answer. So I've got to ask, well, do I know how many atoms are in 1 mole? Can I put mole down here and cancel it out? Well, I know that there are 6.022 times 10 to the 23rd. In this case, I'm measuring atoms, that's my item, per every 1 mole. So my moles cancel out. I have 2 times 6.022 times 10 to the 23rd. And that would give me 1.2044 times 10 to the 24th atoms. Okay, so again, you see how this is just like this dozen calculation up here. If I have 2 dozen, I just took 2 times dozen. Well, in this case, I have 2 moles, so I took 2 times the number of things per 1 mole. Let's do another example. How many moles of, let's go calcium, are there if you have, let's say, 8.00 times 10 to the 25th atoms of calcium. Okay. So how many moles of calcium are there if you have 8.0 times 10 to the 25th atoms of calcium? Okay, so we know we can convert from things to moles and from moles to things, because moles is just a way to count. So let's set this dimensional analysis up. We have 8.00 times 10 to the 25th atoms. Okay, so I know I don't want atoms in my final answer, so I want to cancel that out. So I need to put it in the bottom. Do I know how many atoms are moles? Can I do a conversion factor between these two things? I can. I know that in every 1 mole, there's 6.022 times 10 to the 23rd items. And in this case, the items are atoms. So my atoms cancel out. And now I finish. I have 8 times 10 to the 25th times 1, divided by 6.022 times 10 to the 23rd, which is, give me a second here, comes out to be 132.8 moles. 132.8 moles. Okay, so when we're converting from number of particles to moles or moles to number of particles, this is the conversion factor we're always going to use. Okay, this is called Avogadro's number, right? We know that in every 1 mole, there are 6.022 times 10 to the 23rd items. Right. Now, while that's really useful, okay, to get to know how many particles we are, and remember again, the reason we're doing this is because we need to know on an atomic level how many atoms are interacting. The problem with this is nobody can go out and count this, right? It's not like you're doing a chemical reaction, you stop it, I'm going to go count how many atoms I have, all right? It would take you billions of years to count this high, okay? So there's got to be another way to convert to use this concept of a mole. So what we're also going to learn about is a mole to mass conversion. Okay, so a mole to mass. All right. So on the periodic table, we have the atomic mass. We've been talking about that. So, you know, if we think back to some of those atomic masses, carbon has atomic mass of 12.01. Oxygen has atomic mass of, it's only like 15.999. We're just going to say 16. And the other day I told you these units were AMU, atomic mass units. Okay, so the atomic mass tells me the number of protons and neutrons that are in each atom. It also tells me something else. Okay, the atomic mass is also equal to the molar mass. Well, what is molar mass? Molar mass is the mass of 1 mole of a substance. Or in other words, another way to say this, it's the mass of 6.022 times 10 to the 23rd items of a substance. So what does that mean for us? Let's stick with carbon here. And I'm going to round the molar masses on the periodic table to the nearest whole number. That just makes the calculations a little bit easier. Okay? So if I have carbon, carbon has an atomic mass of 12 AMUs. Okay? Well, what do I know? I know the atomic mass is also equal to the molar mass. But my units are going to change. So carbon has a molar mass of 12 grams per 1 mole. Or you can write it as 12 grams per mole. What does that tell me? Well, it tells me that if I have 12 grams of carbon, I have 6.022 times 10 to the 23rd atoms of carbon. Okay. So another one, oxygen. If we look on the periodic table, oxygen has a molar mass of 15.999, but I'm going to round to 16, so I'm going to say 16 grams per mole. Or if I have 6.022 times 10 to the 23rd atoms of oxygen, it would weigh, or the mass would be 16 grams. Okay, so let's see how we use this. All right, let's actually do some conversions between these. Let's do an example. How many moles are there in 24 grams of carbon? All right. Well, here's my value. So this is the value I'm going to start with for my dimensional analysis. I know that there are 24 grams of carbon. That's my measurement I took. Okay. Well, I don't want grams of carbon in my answer. So I want to cancel out grams, so I'm going to put that in the bottom. And what do I want to go to? Well, I want to go to moles. Okay. Well, from the periodic table, I know carbon has a molar mass of 12 grams per every 1 mole. Can I use this conversion factor to convert away from grams? Yes. I can use this conversion factor to cancel out grams and get to moles, cancel out moles and get to grams. So I know that in every 1 mole, there are 12 grams. So my grams cancel out. I have 24 divided by 12. Gets me 2 moles of carbon. Okay, let's do another one. Let's say I want to know how many grams, how many moles, that's not what I want. I want how many moles are in 24 grams of oxygen this time. So again, I can set my railroad track, my dimensional analysis. I know that there's 24 grams. Okay, I want to cancel out grams. And I want to go to moles. Well, I know on the periodic table that oxygen has a molar mass of 16 grams per every 1 mole. So I can use these over here. I know in 1 mole there are 16 grams. My grams cancel out. And what I come out with is 1.5 moles of oxygen. Okay, so what I do with this is now moles to grams. What that allows me to do is I can go back and measure 16, 24 grams of oxygen really easily. And since I know its molar mass from the periodic table, I now know how many particles I have. Because remember, moles is just a measurement of particles. So this is a really useful conversion because since chemistry happens on that atom-to-atom basis, and I have to know how many atoms I have, well, if I know the mass of any element, I know how many particles I have. So there's mole conversions.